here I've dragged and dropped it. Part B says find the area enclosed by the graph of f, the coordinate axes and the line x equals 2. So I'm looking at this area here, and I can see that for 2 marks I need to write that a equals the integral from 0 to 2 of f of x dx, and that will give me my method mark. And that's going to equal 4.04711895, and I'm looking at 4 decimal places, 1, 2, 3, 4, therefore a roughly equals 4.0479. Okay, now looking at part C, suppose Euler's method is used to solve this differential equation. So this is the same equation, except this is now the derivative, whereas that was the function. Okay, so we're using Euler's method. Remembering Euler's method is f of x plus h will equal f of x plus h times f dash of x, or the new y will equal the old y plus h times f dash the old x, or the value of x prior. So use Euler's method to express y25 in terms of y24. So y24 will equal y25 will equal y24 plus 0.08 f dash of, now I need to know what x24 will be, and I'm going to have 24 lots of 0.08, so 1.92 will be the expression. That's part 1. Part 2 says, given that y24 equals that, give your answer to 4 decimal places. So, over on my calculator, it's going to give me an answer of 4.07032. 2 4 decimal places, 4.0703. Okay, that's part B, part 2 done. Explain why y25 is an estimate of A. Okay, there's 2 ways that I can go about explaining this. The first one is that Euler's approximation for f of x uses x24, y24, and we use the tangent to predict what y25 is going to be, and that triangle, this is 0.08, and the change in y is going to be using f dash of x24 times 0.08, and that's going to give me the change in y, because the derivative at x24 will be the change in y over the change in x, and that's my change in x. This prediction for y25 will not be exact because it's using the tangent at x24, and unless the gradient is constant, that is y dx equals a constant, then y25 will either be an overestimate or an underestimate, and in this case the derivative isn't a constant, therefore it can't be correct. The other reasoning comes from 9g, where we can use the definite integral to solve a differential equation, and I can use this, and I know that x equals 0, y equals 0, therefore d is 0, so y is going to be the integral from 0 to 2, because I'm going to start from 0 because x equals 0, and I'm trying to predict the 25th and therefore the 25th will be 25 lots of 0.08, which is 2, of f of x dx plus b, or d, and d in this case is 0, and this is the same answer as I got in part B. So that's what A equals, and this is what I got for A, therefore it's an approximate, an estimate, it's not exact.